Good point. So this will be missing on the recording, okay? But that's okay. The other ones are probably more, they're trickier than this one. Okay, so I've gathered this. It's not asking me to do this in order to graph, so I wouldn't expect you to have your keystrokes here. This is kind of like an aside for the graph, right? To graph, I need the basics, right? So let's go ahead and graph this. So before I start, I will say time in seconds, and height is in feet. So somewhere over here, height in feet, so it doesn't do anything to us. X-intercept is 2.56, so 1, 2, 3, right? That's what you can do here, 1, 2, and 3, using the markings. They're somewhat faded. I know that I can't control that. That's the printing service that. So 4, 4, 4, 4 would be right here. So this would be the 4 mark there. And I will be able to get my 2.56 in there, no problem. Okay, 2.560, no problem. And then up the y-axis, I need to, the vertex and the y-intercept is the same, but you would have to go by the vertex always, right? Because that will be slightly higher if this had gone up, right? So 0.32, so if I fit in, if I go up by 10, I should have no issues fitting in this graph. So as long as you're consistent, okay? I should probably add that I wouldn't want you to have anything here, like it's just a little corner here. Okay, we're just in quadrant 1 based on the context. So 0.32 would be right about there. And you're not going up, you're just going out and then down. Okay? You put the equation down, you label the points. In this case, the vertex and the y-intercept is the same. That would be a good graph right there. Okay? Let me just check here. Okay. We're good? All right, so this is the graph. That answers A essentially. How long are the buffalo above ground? How long it would be from time 0. So how about we add a 0 here? Why not? Right, from time 0 all the way to 2.56 seconds, right? So that would be the x-intercept. Would be second, no, y2 is equal to 0. I was second, trace 5, and the one I'm interested in is 2.560, so the buffalo stay above ground for 2.56 seconds. Okay, so that's that. C, what's the initial height? It's the y-intercept, and that's just 0c, right? Which is 0.32. Initial height is 32 feet. How long are the buffalo at or above 15 feet? They're essentially saying that what is the time, right, if it's at 15 feet, right? That's really what they're asking you for. So if you want to use a different color, let me see here. I'm going to use red. Essentially, if you wanted to add that to your graph, 15 would be right about there. Okay, this is the 15 line. This is y is equal to 15, right? So how long? Well, it's from time 0 until you get to this point. Okay, so that's the point we're interested in. So we're going to make y2 equal to 15 and then find the intersection. So let's go ahead and do that. Let me just scroll up a little bit. So y2 is now 15. And it does cross it twice, but we do not care about the left here because that's in the negatives, right? We care about the one further out. We go second trace 5 and then enter, enter, enter. And that is 1.86. Right? Is the point that this is happening at, right? So remain at or above 15 feet for 1.86 seconds. Now I want to add something to this. This is an easier case. Sometimes this line that you're graphing is going to cross it more than once, okay? It's going to cross it once on the way up and then once on the way down. Then you would have to subtract those two x values, all right, to get the time that you spent above a certain mark. In this case, we don't need to because it's not crossing it more than once, right? So that's all we need to do there. And you would if it's a 1-mark question, you kind of expect it to just be straightforward. If it's a 2-mark question, then it's going to be more. There's going to be more work involved. So domain and range, we go from time 0 to 2.56, right? The hurt when it hits the ground, it kind of it ends, right? And then range, we go from 0 all the way to the maximum height, which is 32. This is from the x-intercept. This is from the vertex, which happens to be the y-intercept as well. So right, this is from vertex. This is from x-intercept. Okay. So that answers everything here. Okay, so we've done our graph. Sometimes it's more beneficial to graph it first, then answer everything, but you won't always have a choice. You'll have to kind of answer based on the order that I'm presenting it to you. But if you wanted to find all these points first and then graph, sure, it's up to you. Okay. All right. Next page. Right, we have a football team needs to hit the ball between the two uprights. The path of a particular kick can be modeled by this, where h is the height and d is the horizontal distance. So we'll say that every point is distance and height. That's my x, that's the y. And notice that this starts on the ground, right? Starts How do I know that it starts off the ground? Because the y-intercept, which is the initial height, is 0, 0. Okay? Your initial height is that y-intercept, the y value here, which is 0. Okay? So we're going to graph the path, and I'm basically going to ask you to do the same thing again. We're going to do the vertex. We're going to find the y-intercept, which you already know, and the x-intercept. Okay, so we're going to type that in. Type the equation in. Some of you are probably just waiting for me. That's okay. Always watch how you're typing it in. Are you missing an X? Are you, right? Make sure you don't forget that. Sometimes we forget the basics and that throws everything off, right? Don't forget the basics. Hit graph and there it is. I did expect this to be a wide curve, right? We did expect that, so no surprises there. I'm going to increase my X max. I'm looking at 10 already, so I would go 50 to be safe. So that does the trick. I'm a little short on the top here. So I'm going to increase my Y max to like 40. And now I see the whole thing. Let's find the vertex. Second trace, it's a maximum. Go to the left of the vertex, hit enter, go over to the right, enter, enter. So that's 17.08 and 35.02. Y-intercept is 0, 0. X-intercept, you can kind of tell that this is going to be 0, 0. If you're not sure, check it, okay? But you know that 0, 0 is a point on the graph, right? Just by looking at the y-intercept. So it would have to be. So I'm going to focus on the right side. Enter, enter, enter. So that's 34.170 and 0, 0, right? If you're not sure, check over to the other side. Enter, 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 and it's 0, 0 there. Okay, so you found them. So that's basically what you need to graph. So let's go ahead and do that. This is going to be distance, and that's going to be in. Distance is in yards. Tricky, right? Distance is in yards, and height is in feet. Okay, so for the x-intercept, I need to include or make sure I have for enough room to fit in 34. So I think if I go up by 10, I will be just fine. So I'm using a scale of 10 for my x. You're starting at 0, of course, 0 here. And we're going to make sure we have enough room for the y value of the vertex, which is 35. So I'm going to go 10 as well. 10. Make sure you're consistent, right? I'm counting every fourth mark, right? So if I do 40 there, 40 there, I'm good. Now plot the points, 0, 0 here, 34, 17, so it's just over here, and 17, 08, 35, 02. What I essentially want is if you get to grade 12 and you have, Miss Yosik or Mr. Erickson, they're like, oh man, like graphing is just a piece of cake for you. It's like, yep, we know how to graph, right? So again, maybe start with the vertex, go out and down. Same here, out and down. We're going to make sure that we have our equation. Boom, you're done. This is a full mark. You get full marks here. You have labels on the axes. You have your scale. You also label the important points, right? And you have your equation on there. Okay. Now that's a B. How far from the player does the ball land? Right? So Obviously, if you kick it from here, it lands right there. So we'll just say, because I would expect you to tell me what the keys are. So that's the point. So it lands 34.17, what is it, yards from the player. See? If the ball is kicked from 30 yards, how far above or below the crossbar is the ball? What happened there? If the ball is kicked from 30 yards. Oh, yes. This question might be a little confusing. I'm trying to see what was I thinking when I was wording it. And this actually had an image attached to it, like a diagram from an old grade 12 provincial exam. So quadratics comes back there. So basically, if the goal is right here, so I'm going to use a different color. I'm just doing this for illustration. So let's say the goal, the football net is right about here. So right, like if this is the net and you're kicking it from 30 yards back, right? Will you be above or below the goal line? Basically, that's what I'm asking you. Okay. How far above or below is the crossbar? But I didn't tell you how tall this thing is. So you know what? If you were scratching your head, I apologize. Let's scratch this question. I was supposed to tell you how tall that net is, right? And I didn't give you that information, so let's just not worry about it. And I was also looking at the wrong question. What's the maximum height of the ball? That's C, right? So it's the vertex. The maximum height is found at this location. And now it's on record, right? That I made a mistake because I'm recording it. That's also, so D, don't worry about it. Okay, cross D. E, state the domain and range if the horizontal distance is restricted to where the goal is. I will tell you the goal is 30 yards from kickoff. Okay, so basically 30 yards from where you kick it, that's where it ends for us. That's where the action ends. Okay, so for E, just write down the goal is 30 yards from the kickoff point. Okay, so how would that change for my domain? Write it down first and then I'll do this part. Make sure that's written down. I have to fix this handout. Yeah, don't like that. So if the goal is 30 yards from the kickoff, that's when the action ends. So I know we kept on going with the ball. Obviously it lands here, but let's say it ends right here, like 30 yards from the kickoff. So that my domain then would be 0 to 30 because I'm telling you that the action ends there. And range would be still from 0 all the way to the highest point. So that one isn't affected. is the highest point, and this is where I'm telling you x-wise in terms of your x values, it ends when you get to the goal line. Okay. F was supposed to get you to think. Okay. I don't know if it did that. D, I apologize. If you were scratching your head over that one, that's totally my fault. But F, an equation, you want an equation with a lower maximum height. How would you do that? They're basically saying, hey, come up with one, right? They're basically saying, come up with an equation. So what I want you to look at is, I will give you the one that they stated up there. This is the original. That's the original equation right here. How would you be able to come up with an equation that would have a lower maximum height? How would you acquire that? It has to do with this value right here. If you were to make this even smaller, right, the curve would go from this to something that is wider, right? The smaller you make that A value, the wider the curve becomes, so it kind of flattens down, right? So you want to bring this down like that. So what we do is we reduce A. So how about we do, to make it smaller, right? Let's reduce that to half, 0.06 d squared plus 4.1 d. Leave everything else alone and just do this. Just highlight that point, right? This will create, right, a wider curve with a lower max. So I halved it. You could have done, by the way, you could have gone 0.10 if you wanted to and put that down, and you would have achieved that. Okay. If you don't believe me, let's see if that actually works. So go to your calculator and type it in Y2 at the same time. Okay, so we're going to go negative 0.06 x squared plus 4.1 x. Let's graph them both at the same time. Wait a minute, something went wrong. One second. Oh, yeah. Okay. Do you notice what happened there? You actually need to get it closer to 1. I apologize for that. I don't have my answer key in front of me, but you should slightly increase it. What I did is I doubled it, getting it closer to 1, and then it did the trick. So instead of 0.12, I went 0.24. Watch that. 0.24, I doubled it. If you do that and you hit graph, it will actually create a graph with a lower maximum, right? Because the red one is the one we're after. This is what we want. So let's change that in our notes, okay? I'm going to go 0.24. . Okay, get it closer to 1. I'll make a note here. Increase closer to 1. That's what you want to do. Okay. All right. Now we're going to do the second worksheet. Okay. So I'm going to walk you through probably at least one, if not both questions. Okay. So that's why I hope you saw what I just did here. This is an amazing tool, right, to check for answers instead of just blindly uh, doing something, right? The other one would have been, if you kept this at 0.12, you could have also, even though this would somewhat change the actual curve, if you reduce the y-intercept to, like, let's say -1, right? If you reduce the y-intercept to -1 and you graph that one, you will actually get a curve that's slightly lower. See there? It's slightly lower, not by a whole lot. If you added a -10, because remember the intercept at the end either raises or lowers the curve. Okay, so if you have a -10 at the end and you graph it, the difference will be even more noticeable, right? So that is another way of changing the max. You reduce the y-intercept, okay? So this would be also a parabola, but it's just lower. Okay, so if you want to add that to your notes here, how about this? We could also decrease the C value, right? Example, we go HD -0.12 D squared plus 4.1 D minus 10. Okay, sorry about that. It's very small, I know. But you should be able to understand what's happening there. Okay? That's also an equation that would result in a lower max. Okay? In fact, I should have probably just stuck to this instead of also talking about A, but both of them, or a combination of, changes it. Okay? And the reason why I'm talking about this is because it's quite common in grade 12 applied that a question in the provincial exam says, what could you change in the original equation to make it, to make the cake be further away from you or something like that? And that's where you come in and use technology to help you answer that, okay? And the knowledge of what the different components do, okay? All right, worksheet 2.0, okay? This one is a little different. I don't know if you've noticed it, the parabola will open up, right? And you can tell by the equation here that that is going to be the case. Okay, so Kamal and Aries are working on a project for the physics class, which involves designing a flying object that can remain airborne for at least 10 seconds. Kamal designed a paper airplane and begins throwing it toward Aries, who stands opposite to her. The flight stops when Aries catches it at the same height it was thrown. One particular flight can be modeled by, notice that it says catches it, right? I would say flight stops when it's being caught, right? So I would say that that's important to note later for the domain and range. So again, this one points up and it's wide, the y-intercept is 0, 1.6. Okay, right off the bat, you can tell that from just looking at that. And time is in seconds, so time is the x, and whatever's to the left is your height. And that's your x and your y. Okay. What is the initial height of the plane? We can answer that. It's the y-intercept is the initial height. Right? So 0, 1.6 is the y-intercept. So initial height is 1.6 meters. Because it's in meters, right? How long does it take for the plane to reach Aries? There we have to probably do some math, right? So I'm not asking you to graph it just yet. So let's type this in. That's actually one of the first things I do when I am given an equation, right? So you go 0.036 x squared minus 0.4 x plus 1.6. And let's try to get this on our screen. And we do get it, which is good. So essentially, I will just make a sketch here. I will not make a graph without an appropriate scale. But essentially, Aries is here, throws the airplane, and it will be caught on the other end, right? Right at this same point. So we need to figure out how much time has gone by from where it was launched to where it gets caught, right? So yes, the parabola keeps going, but this is really what we're after. So we know that this is the line y equals 1.6. So because it gets caught the same height as it was launched, right? You know, there's a 0.01.6 here, and it's again 1.6 here. So we just need to find the x value here. So they're essentially asking, right, what's the x there if y is 1.6? So to find that, we're going to make y2 equal to 1.6. Then we're going to go second, trace 5. So go to your calculator, type in 1.6. And it's a little small. So you know what I'm going to do? I'm going to go zoom 6, okay? Because I know that I'm going to be closer to the action here. I'm going to increase my x max by a little bit. Just by a little bit. And there I see it, right? The action is really just right here. Okay, it starts here and would stop there. So let's go and find that intersection of the second encounter. Enter, enter, enter. And that is 11.11, 1.6 is the intersection, right? So it takes 11.11 seconds to reach Aries. Okay. Again, you have to be careful. If this curve, if it would have been here, somewhere down here, and it crosses it twice, then you would have to subtract. Technically, we subtract here as well, folks, but it is 11.11 minus 0, which is just 11.11, right? So it stays the same. There's no need to subtract. How long does the plane stay at or below 1 feet? 1 foot, sorry. So what we're going to do there is make our y2 equal to 1. second trace 5. And what is this going to look like? I'm going to go and change my y2 to just 1. And I'm going to see it on my graph here. There it is. This is the 1 foot line, right? The height of 1. So it happens here. The plane comes down, gets to 1 foot, stays below it, and then gets to the 1 foot mark again on its way up. So there are 2 instances that happens. So we're going to find that intersection twice. So the first one, way down, it would be 1.7876 if you round it. Way up, let's go ahead and find a second trace 5. I'm going to go all the way to the other side. Enter, enter, enter. Okay. And there is 9.3235. Sorry, I don't know why I'm putting 0 down here. That's supposed to be a 1 here. Okay. So it is happening twice. So delta time, right, we go 9.3235 minus 1.7876. I'm going to quit this screen and there it is. And it's 7.54 seconds. Now I can round, okay? At or below 1 foot. All right. D, state the domain and range. The domain would be from time 0 to where it's caught, right? So that'd be 11.11. You're done. The range, this one is tough. This one is a tougher cookie here. How do you know what the range is? Let me just go slightly up here. The range is really, right, it's trapped between 1.6 and the lowest point, which is your vertex. Okay, it's between there that the y values are trapped. They're trapped in between those two. So find vertex first, right? Vertex is, let's go ahead and find it. I would expect you to know that you have to find a vertex here. I wouldn't tell you, okay? So I'm going to graph it. Second trace, in this case, it's a minimum, okay? It's not a max. And I'm going to go to the left of it, left boundary, enter, right boundary, enter. And the minimum is at 5.56, 0.49. This being the lowest height, right? It happens after 5.56 seconds, but this is the height it reaches, right? Time, height. So this is what you're going to put down here. And notice that I'm going to start with the lowest value and end with the highest of the two. You have to, the order matters, okay? Those of you who like set notation, This would be 0 greater than or equal to time less than or equal to 11.11 squiggly brackets, or 0.49 greater than or equal to height less than or equal to 1.6. And there you have it. So this one is a trickier one. Yes, domain and range here is definitely tougher here because I didn't ask you to find a vertex, or I didn't ask you to find the lowest point at any time yet. So this is part of it, right? I would say here it's a min, okay? Lowest point. So now we can graph it. And you basically have a lot of information here that will help you with it, okay? So I'm just gonna go here and say that this is time in seconds, height in feet. No, the height is, I know, you're probably saying there's feet and meters at the same time, right? Because I believe in feet and time is in seconds. Did I say meters at one point? I think I did. And A, supposed to be feet. Yeah, let's just change that to feet. My bad. I knew that I had mentioned meters at one point, and I think when I wrote this up, I meant to say meters because, right, the average height is 1.6 meters. It's a 1.6 feet is like really low, but it is what it is. We'll just leave it. Because I used feet up here, let's just keep it feet, and then it's fine. So height and feet. So my time is 11.11, right? So I have lots of room. So 2, 4, 6, 8, 10. 2 is a little small. You can go up by 5, maybe. Sure. 5, 10, 15, 20. That's good. Maybe a little narrow, but it doesn't matter as long as it's consistent. We're not making you use a certain scale. And for my height, the highest I'm getting to is 1.6, right? So if I make this 0.5, this mark right here, then this is 1.0, this is 1.5, and this is 2.0. So I have an appropriate scale there that you don't want to cram it in. You want to make sure you have enough room. So look at the space you have and try a few things, right? Before you do that. So now 11.11 is right about here. I'm going to label it. My y-intercept is 1.6, so it's right about there. Right? My vertex is 0.49, 5.56, sorry, 5.56, so this is 5, and 0.49, which is very close to 0. And this is not right either, the 11.11. Is it Friday today? Because it feels like I'm making too many mistakes. Yeah, I know. I was hoping for Friday. Okay. 11.11 is at 1.6, right? Because I'm thinking, why is there a point here? My curve is supposed to go back up, right? 11.11, 1.6, so I should be right back where I started, right here. Now we're talking, right? So out and up, and then out and up there. Okay, this is 11.11, 1.6. This is 5.56, 0.49. And I've got all the points labeled. The action stops there. It doesn't continue. And so that's your graph right there. Okay. Cedric, it's a good question. So for C, if you had rounded to 2 here and 2 here, I will, the province and myself, I will always use like all decimals, most likely. So if you do the work and you end up with the same answer, you wouldn't lose any marks because we would just assume that you used all decimals, okay? But most likely you're going to be off. So use at least 4, if not all of them. All of them would be ideal, but at least 4, okay? When you're doing, because this is not your final answer yet, this is your final answer. So before we get to our final answer, we use more decimals, okay? Good question. Yeah, no problem. Good question. All right, let's see if we can fit this in. So I think what I wanted to get to is regressions, but I'd rather spend time on this because it's important. I think I want to end with you spending some time on your own. I have a sense that quite a few of you did not make it all the way to here. And I hope you tried it at least. So I'm going to just stop here. I'm going to get you to go through this on your own for the rest of today's class. And I will post the answer key shortly. Okay, I actually have it ready to go already. The answer key might look a little different than what we did today because I just did this from scratch. Okay, so I actually probably added more notes to this one than the answer key I will give you. But if you have any questions, you can just ask them tomorrow. But there is, if I look at F here, it kind of it deals with what we just did earlier when I actually got it wrong myself, right? I gave you the wrong equation there, but now you should know what to do, okay? So that's what we're going to end with. Tomorrow we will do regression, so it's very important that you're here. Don't miss it. It's basically coming up with the equation by just giving some points to the calculator. And so it's quite a process to learn how to do that. Once you know what to do, it'll be fine. But that's that. Okay, so thank you for your participation, attention, and so if you haven't done this, this is the rest of today and homework. I don't think I have a handout for you ready. So let me see here. Don't leave just yet, okay? Can you also write down these two questions? There's only two questions I want you to do in addition to this for homework, okay? One of them is a word problem that I want you to do a graph for as well. They don't ask for it.